Right, children? So, we are going to start the next chapter of this lesson. Do you remember what we learned in the previous chapters? We learned why sunlight or the heat given by the sun is important for the existence of life. And further, we learned that how to generate heat. There are different methods of generating heat. We learned different methods of generating heat. Okay? Now here we are going to learn about effects of heat. Right? We'll go through this one. During daytime, the environment becomes hot. Now we already discussed about this. Okay, children? During daytime, the environment becomes hot. Why? What is the reason? Because different places, different objects present in the environment absorbs the sun's heat. Okay, children? At night, it becomes cold. Okay, children, at night it becomes cold. Why? What is the reason? Because during the night time, there's no sun, there's no sunlight, therefore, there's no heat given by the sun. Therefore, the objects that got heated up during the daytime start to release heat towards the environment. Okay, children? Therefore, at night, it becomes cold. Okay. When we take an ice cube out of the refrigerator, it turns into water. What happens when we take an ice cube out of the refrigerator, out of the freezer part? It starts melting. So when it is in the freezer, when it is in the ice state, it is a solid. Right, children? When it melts, what happens? The solid water, the ice turns into liquid water. Okay, children? Right, when we take an ice cube out of the refrigerator, it turns into water, which means change of state of matter takes place. Okay, children, next one. Before fixing a rim to a cartwheel, rim is heated well. Rim is heated well. What is this, children? What is the meaning of this sentence? Now, some of you may know what's happening here. Now, most of the time when we consider the cartwheel, it is made up of wood. Okay, so when we use the cartwheel, it wears out and therefore we have to protect this cartwheel so that we can use it for a long period of time. Right? So, let's say if this is the cartwheel. Right. So if this is the cartwheel, so as this is made up of wood, when we use this, what happens? It gets damaged and it wears out. Therefore, to protect this outer part of the cartwheel, we can fix a wooden rim to this one, wooden frame. This rim is a kind of frame. Okay, children. So when we fix this metal frame, the metal frame that we are going to fix should be tightly fixed to the cartwheel. In that case, what do you think about the size of the metal frame that we are going to fix this one? The size of the metal rim or metal frame should be either equal to the size of this cartwheel, or it should be, the size of it should be little less than that of the size of the cartwheel. Right? So, I will draw this with different color. Right? Okay. Let's consider this is our metal frame or metal rim. Okay, children. So now, if this is smaller than this cartwheel, or if it is exactly equal to the size of the cartwheel, how are we going to fix this? Now, when we fix this, the cartwheel should be inside this metal frame. Okay, children, how are we going to fix it? Just think, children, if we can increase the size of this metal frame for a short period of time, we can nicely insert this cartwheel in this metal frame. Okay, so how to increase the size of this metal frame, children? We can heat this up. By heating, we can increase the size of the metal frame. Right, children? So, in the other topics, we are going to learn about when we provide heat, the size of the object increases, and this is known as expansion. Understand, children? So, what happens when we heat this metal rim? It expands. Okay, which means the size increases. So when the size is increased, we can fix this to the cartwheel nicely. Right, I'll draw it here. So after fixing this metal frame, it should stay around the cartwheel like this. Okay, children, so this is the metal frame tightly fixed around the cartwheel, right? This whole part is the metal frame. Okay, children. So now, what is the method of doing this? We can heat this metal frame up. So when we heat it up, what happens? The size of the metal frame increases so that we can insert this cartwheel inside this metal frame. So how to reduce the size? Because this metal frame, the size of the metal frame is increased, now we have to bring it back to the cartwheel size of the cartwheel, then only it fixes with each other very well. So how to reduce the size again, children? This automatically happens when this cools down, or we can pour some cold water into this metal frame. So when we pour cold water into this metal frame, its size comes back to its original size. Okay, so as its original size is quite equal to the size of the cartwheel, when we bring it back to the original size, it nicely fixes to the cartwheel. Right, so after that, using nails, we can fix it really well. Okay, children, so this is known as expansion. Now, when we provide heat, the size of the objects increases, and this is known as expansion. So that is another effect of heat. Okay, children, so we can observe changes in an object not only when we supply heat to it, but also when the heat is removed from the particular object. Right? So this is a good example. You all know when we supply heat, its size increases. It is known as expansion. So again, when we reduce the heat by pouring cold water into this metal frame, what will happen? Its size reduces. That happens because of the reduction of heat from this object. Understand, children? So in this way, it's very clear there are different changes take place because of heat, and these are known as effects of heat. Right? So under this topic, there are several effects of heat. We are going to discuss about 4 effects of heat. Let's write them down. So the first one we discussed here, increase in temperature. Increase in temperature. So here we are going to discuss that when we provide heat, the temperature of the objects increases, right? Number 2, expansion. Right? So under this topic, as here we are going to discuss that when we provide heat, what happens to the size of the objects? Increase. Next one, change of states of matter. Change of states of matter. Right? There we are going to discuss that because of the temperature changes, the states of matter also changes. Okay, children, here we discussed when we take an ice cube out of the refrigerator, it melts, which means solid turns into liquid. Likewise. Okay, and the last one we are going to discuss about is color change. Right. So what about color change, children? Sometimes you all know that when we dry clothes outside under sunlight, when it happens for a long period of time, what happens to the bright colors of the clothes, children? The bright color reduces and it fades out. Okay, this happens because of the heat, temperature. Okay, children? So color change also takes place because of change of heat. So under effects of heat, we are going to discuss under 4 topics. What are they again? Increase in temperature, expansion, change of states of matter, and color change. Okay, children? We'll move on to the next. Right. So under this one, we are going to first discuss about increase of temperature. Right. So we have an activity to do. Let's observe how temperature of water is changed. Right. So what are the things we need to do this activity? We need a water beaker and we need a tripod. This is a kind of stand that you can place this beaker on. Right. So a spirit lamp and a thermometer. We'll write water beaker, tripod, spirit lamp and thermometer. Right? Water beaker, tripod, spirit lamp and thermometer. Right? How to do the activity? Look at the method. You have to set the apparatus like this. Prepare the setup as shown in the above diagram. Let's label this. So this is the spirit lamp, tripod, this is water and the thermometer. And we can fix the thermometer using a laboratory stand. Label that as well. Spirit lamp, tripod, water, label beaker as well. This is the beaker. Thermometer, and laboratory stand. Okay, thermometer, water, tripod, spirit lamp, beaker, laboratory stand. So when you draw a diagram and label it, it's very clear that what we have to do. Okay? Right. Prepare the setup as shown in the above diagram. Light up the spirit lamp and observe the change of temperature mentioned in the thermometer. So before we start this activity, first we have to measure the initial temperature of the water. Okay, children? After that, we have to light the spirit lamp and we have to observe what happens to the thermometer reading. Okay? So then blow out the spirit lamp and observe how temperature changes. Right? Light up the spirit lamp and observe the change of temperature mentioned in the thermometer. Here you are going to observe the temperature increases. The thermometer reading increases and at one point the water will start to boil. Right, children? And when you remove the spirit lamp, you are going to observe that the temperature reduces. Right? As long as we supply heat, the temperature will increase, and when we remove this spirit lamp, what will happen? The temperature will reduce. We will do this activity now. Right, children? So with this activity, we are going to observe how the temperature of water is changed when we provide heat. Okay, children? So can you see the setup? So you all can see this is a laboratory stand. So to this laboratory stand, a bulb thermometer is fixed here. This is calibrated in Celsius scale. Okay? And the bulb of the thermometer is immersed in this water beaker. You all can see there's water here. And we are going to use a spirit lamp to heat this water. Right? So I'm going to light the spirit lamp up. Right. You all can observe what is the initial temperature, 24. So now when we provide heat, this water absorbs the heat. Water is absorbed by the heat and the water will get heated up. Therefore, the temperature of the water increases. If you observe carefully, after a little while, you will see that the temperature increases. Using the thermometer, you can see what is the temperature, okay? Right, children. Can you all see now at this time temperature is 29 degrees Celsius. It's gradually increasing. Now it is at 30. So why does this happen, children? This water absorbs the heat and therefore the temperature increases. You can see now at this time it's at 35. Can you all see from here? Temperature is at 35. Right. Now the temperature is at 40. Right, children. Observe carefully. Now it is at 45. Now it is at 50. Observe carefully. The temperature is at 50. Now you all can see the temperature is at 62 degrees Celsius. Look at the water beaker, children. You all can see tiny air bubbles rise. And the temperature is about 68 degrees Celsius now. And you all can see it is reaching 70. Now you all can see there are more air bubbles in the beaker. At the bottom of the beaker, observe carefully, children. There are more air bubbles. So which means this water is going to boil now. This is why tiny air bubbles form, okay? Look at the temperature. Now it is at 77. And now it's gradually increasing. It's going to reach 80. You can see these tiny air bubbles go up, right? It's very close to boil now. Look at the temperature, children. It is at 85. So when you do this activity, it's very clear. When we provide heat continuously, the temperature of water also increases continuously, okay? So according to the increase of temperature, the thermometer reading also increases. Now it is at 90 degrees Celsius. You can see now water is about to boil. So you can see many air bubbles from bottom, many air bubbles arise. They move up and the temperature is also increasing. You all can see. Temperature is at 95 now. You can observe clearly. Look at the beaker, children. There are more and more air bubbles. Water almost started to boil. Okay? Now this time air bubbles are bigger than earlier. Right? Earlier the air bubbles were very small. Now bigger air bubbles. When the water starts to boil properly, you will realize the air bubbles are way bigger than this. Okay? Temperature is at 98 degrees Celsius now. Okay, children. Now you all can see the temperature is at 100 degrees Celsius. And water is boiling really well. You all can see water is boiling very well. If you observe, you can see the temperature is at 100 degrees Celsius. So we are going to wait for another minute to check what happens with the temperature to it, whether it increases more or not. The water is boiling very well. So look at the temperature now, children. We waited for about 1 minute. You can see the temperature is still at 100 degrees Celsius and water is still boiling. You all can see very clearly, right? So after doing this experiment, it's very clear when we provide heat, the temperature of water increases and at one point water will start to boil, that is 100 degrees Celsius. But while the water is boiling, even though we provide heat, you can see the flame of this spirit lamp, which means we are still providing heat. Okay, children? So even though we provide heat, Even though the water is boiling, at this point, while the water is boiling, the temperature of water remains the same at 100 degrees Celsius. Right, children? So you observed what happened. You all know that we heated the water. So we measured the initial temperature, and after that we started to heat this water. Then what happened, children? This temperature increases. Right? At one point, the water starts to boil. What was the boiling temperature, children? 100 degrees Celsius. Right? So water started to boil, and we observed carefully during the time that water is boiling. Does the temperature change, children? It does not change. Right? While the water is boiling, the temperature does not change even though we supply heat. Right? While the water was boiling, we did not remove the spirit lamp. Right? The spirit lamp was always there throughout the time we were doing the activity. But during the time that water was boiling, the temperature did not change. Okay? Right. We'll write this down. When heat is supplied, the temperature of water increases. While the water is boiling, what happens? The temperature does not change. Right, children? When heat is supplied, the temperature of water increases. While the water is boiling, the temperature does not change. So what is the conclusion? When heat is supplied, the objects get heated up. Right? We will write. When heat is supplied, the temperature of objects increases. Okay, children? When heat is supplied, the temperature of objects increases. Okay? Right. We'll move on to the next. Right. So the same thing is here. When heat is supplied, the temperature of water increases. Although the heat is provided while water is boiling, temperature doesn't change. It remains at the same value, 100 degrees Celsius. Right? When heat is supplied to an object, it becomes hot. Right? It gets heated up because its temperature increases. Understand? So what is this temperature, children? Now we all know heat means a type of energy. Right? So let's see this. The amount of heat of an object is known as temperature. Heat is a type of energy. What happens? The amount of heat present in a certain object is known as its temperature. Right? So the amount of heat of an object is known as temperature. Right? Heat can be measured by using a thermometer. Thermometers are, there are different types of thermometers, children. Right? There are different types of thermometers. I am going to explain in another part of this lesson. So you know that the temperature of food increases when it is cooked. In the same way, when the heat is released, the temperature reduces. We discussed this earlier as well. During the daytime, things in the environment, different places of the environment gets heated up, the temperature increases. During the night time, because there is no sunlight, what happens? They get cool down, right? So, temperature of food increases when it is cooked. In the same way, when the heat is released, what happens? When the heat is released, the temperature reduces. Understand, children? According to this, we can come to a conclusion that when heat is applied, the temperature increases. When heat is released, the temperature decreases. This is very important. When heat is applied, the temperature increases, and when heat is released, the temperature decreases. Right, children? This is one effect of heat. So, under this chapter, we are going to learn about effects of heat. So, this is one effect of heat. Right? Increase of temperature. Right? Okay. We have an assignment to do. Take two equal-sized beakers and put equal volumes of water. Equal-sized beakers, equal volumes of water to one beaker and coconut oil into the other beakers. We take two similar beakers. To one beaker we have to put water, and to the other beaker we have to put equal volume of coconut oil. Right? Coconut oil into the other beaker. Heat them using two equal-sized candles. Both the vessels. Now here, heat them using two equal-sized candles, which means we have to provide the same amount of heat. Okay? Both the vessels should be heated for an equal period of time. Equal period of time. Identify what is heated more. Right? So, we do this activity to find out whether two different substances get heated up in the same manner. Right? So, I'll draw a diagram to understand this better. How to do this activity? You have to take two similar beakers. Let's draw beakers. Two similar beakers. Like this. Another beaker. You have to place them on a tripod like this. And then you have to put equal volumes of liquids. To one you have to put water, to the other you have to put coconut oil. Right? Using two similar size candles, we have to heat them up. Right? Two similar size candles should be used, which means we have to provide the same amount of heat. And we have to measure the temperature with the thermometer. Right. This is the bulb of the thermometer. And we have to heat them for the similar time period. Right? We'll label them. Beakers of similar size. This one is water. This one is coconut oil. And these are the thermometers and tripods and candles. Right, children? You write. Beakers, thermometers, tripods, candles. Here, coconut oil and water. Right, children? So, can you think what is the reason to use the similar conditions, children? Only the type of the liquid we use is different, right? Similar size beakers, similar size candles, similar volumes of liquids, right? What is the reason, children? This is done in order to increase the accuracy of the experiment, right, children? So we are going to change only the liquid, which means all the other conditions should be the same, right, children? So otherwise, when the result is different from each other, sometimes we might think, okay, we use two different sizes of beakers, that is why the result is different. Or maybe we may think like, all right, we use different sources of heat, that is why the result is different. That is why all the conditions should be the same except for the condition that we are going to check. So we are going to check two different types of liquids, therefore only the liquid should be different, all the other conditions should be the same. In this way, we can increase the accuracy or the correctness of our experiment. Understand, children? Right. We'll do this activity now. Right, children. Now we are going to do this activity to prove that even though we provide the same amount of heat, different types of liquids increase the temperature in different amounts. Okay. So as I explained y'all, we need equal volumes of coconut oil and water. Y'all can see these are of the same levels, right? And similar types of boiling tubes are used here. And we are going to use a candle to heat. You all can see the thermometer is clamped using this laboratory stand, right? And this is a stop clock to measure time. We are going to heat these two liquids during the same time period, and we are going to check how the temperature rises, okay? So first I am going to heat the water sample. So I am going to fix this boiling tube like this. And we have to make sure that the bulb of the thermometer is immersed in liquid. Right, children? Right. So afterwards, we are going to measure the initial temperature. Look at this, children. So if you observe carefully, you will see that the initial temperature is 25 degrees Celsius. Right? You all can see this very clearly. 25 degrees Celsius. Now what I have to do is I am going to light this candle and I am going to place this candle right under this boiling tube, and at the same time when I am placing the candle under this boiling tube, I am going to turn on the stop clock, right? And we are going to measure within 1 minute, okay? So we are going to heat this water for 1 minute, and afterwards we are going to observe what happens to the temperature. If you observe carefully, you can see the temperature increases. Now it's reaching 30 degrees Celsius. Right, we passed 30 seconds. And the temperature is rising 39, 40 degrees Celsius. Right. Temperature is also increasing. Right. Okay, 1 minute. We are going to remove this candle. Right. Now we are going to measure the temperature. If you observe carefully, you will see the temperature is at 57 degrees Celsius. Right. Okay. Initial temperature was 25. The final temperature after heating for about 1 minute, temperature is 57 degrees Celsius. Okay. Now we'll take the other one. I'm going to remove this. And then I'm going to take the coconut oil sample and fix the boiling tube as in the same way. Right. We are going to wait for a minute for the temperature to drop here. That is because earlier the temperature was there up to where the temperature of the water rise. Now here we are going to wait for about a minute so that we can measure the correct initial temperature of this coconut oil. Look at the reading, children. You all can see it is 25 degrees Celsius. So initial temperature of coconut oil also 25 degrees Celsius. So now we are going to again place this candle under this boiling tube, and at the same time I am going to switch on this stop clock. Observe carefully. We pass 30 seconds. And now about 50 seconds. One minute. Now let's check the temperature. You can see it's still rising, but we removed the candle. We have to wait till it stops and then we are going to take the reading. You all can see it's still rising. Right. You all can see now this temperature stopped at 83 degrees Celsius. If you observe carefully, you can see it is at 83 degrees Celsius. Right, children? So what happened, children? When we were heating water, the temperature increased from 25 degrees Celsius to 57 degrees Celsius. But when we were heating this coconut oil, what happened, children? It increased from 25 to 83 degrees Celsius. So which means coconut oil gets heated up faster than water, right? So by doing this activity, it's very clear that when we use different types of liquids, the temperature rises in different amounts. Right, children? So you observed what happened. What did we do? We heated two different types of liquids under the same conditions, right? Same beaker, similar thermometer, the same spirit lamp we used, and we heated them up for the same time period. What happened, children? You all observed very clearly that the temperature of the coconut oil increases faster than that of water, right? Which means coconut oil gets heated up more than that of water. Okay, we'll write this. Do you remember what were the readings? Water, the temperature of water increased from 25 degrees Celsius to 57 degrees Celsius. Right? Coconut oil. Coconut oil, what happens? Started from 25 room temperature, and within the same time period, coconut oil, what happens? It heated up to 83 degrees Celsius, which means starting from the same temperature within the same time period, the coconut oil gets heated faster, or it gets heated more than that of water. Right? So after doing this activity, it's very clear different types of liquids, different types of substances get heated up in different manner, different way. Right? So here, identify what is heated more. Even though both beakers are heated equally, their temperatures have not increased in equal amounts. Right? Even though both beakers are heated equally, their temperatures have not increased in equal amounts. Right, children? So I hope you understood clearly. Right. Our second topic under this chapter is expansion. So you all know that we are learning about effects of heat. So we learn about increase of temperature as the first effect of heat. And now we are going to learn as a second effect, expansion. Now I already explained part of this expansion. Do you remember I explained you how can we fix a metal rim to the cartwheel? So under that I discussed about expansion a little, right? Look at this one. Have you observed that the rails of a railway track have been fixed keeping a gap between them? Have you ever observed this, children? When we consider the railway, you all know that railway is made up of metals, right? So it is made by fixing metal bars, a kind of shorter metal bars with each other, right? Closer to each other. But have you ever observed when these metal bars are fixed? Right. Let's consider this is one metal bar of the railing. Right? This is the other metal bar. Right? This is the other one. Likewise, by connecting these type of metal parts, the railway track is made. Okay? This is one side of the track. This is the other side of the track. Okay. There also you will be able to see that there are gaps between rails. Okay. Like this. So this is the railway. You all know that when we fix these rails, we fix them on sleepers. We'll draw sleepers so that you can understand this better. We can consider these are the sleepers. Normally we lay these rails on sleepers and fix them. Right. So I'll draw only two. So I think you can get an idea how it happens, right? This is the railway track. These are the sleepers. This is where the train moves on this railway track. Okay, children? So what happens here, children? What is the reason for leaving gaps between the rails? What happens here? Do you know that during the daytime, when the environment gets heated up because of the sun's heat, what happens? What do you think would happen to these metal rails, children? Obviously, they also get heated up really fast. That is because the rails are made of metals. Metals can absorb heat really fast and therefore they get heated up. Now we already discussed that. What happens when objects absorb heat? What happens to the size of the objects, children? The size increases. So here what happens, children? When these rails absorb heat, what happens? Their length increases. Right? The lengthwise size increases. So during the daytime, what happens, children? Because of heat, the length increases. So the increased length we will draw like this. This is the increased length. Right? Even this one also, the length increases. Okay? So this is the increased length. Even this trail, this is the increased length. Okay? Same happens here as well. Right? The length increases than the usual way. So when the lengths increase, the gaps close. Right? When the lengths increase, when the lengths of the rails increase, what happens to this gap? This gap closes up. Okay, now these are the increased lengths. Increased lengths of rails. Why does this happen again? Because during the daytime, the environmental temperature increases. When heat is absorbed by these metals, these are solids, right? What happens to the length? The size increases, thereby here the lengths increase. So because we have left a gap between two rails, they have enough space to increase their size. Okay, children? So to facilitate the expansion, we have to leave these gaps. You all know that increase of size of objects due to heat is known as expansion. I explained it earlier. Right? Now here when it comes to rails, during the daytime, the rails expand. Right? When they expand, their lengths increase. Right? So they should have enough space to increase their length. Okay? So to facilitate expansion of these solids, these metal rails, we have to leave gaps when we fix them. Right, children? Just imagine what would happen if we did not leave gaps between two rails. Right? Let's see. Let's consider. These are the two rails. So without leaving gaps, we fix them like this. Two rails. So during the daytime, due to expansion, what happens to the length? Length increases. So then if there's no space between these two rails, what will happen? How can they increase the length? There's no way to increase the length. Therefore, when they are trying to increase the length, they bend outwards like this. Right? When they are trying to increase the length, they bend outwards like this. Even from this side, they bend outwards. Now what will happen? The shape of the railway changes. Now this is pretty dangerous, children. So what will happen, children? When the shape of the railway changes, trains cannot move in the same way. From here, they will derail and accidents might occur. Okay, children? So this is a very dangerous situation. That is why we have to leave gaps when we fix these two rails. Right? Between two rails, there should be a little gap so that it's very important to facilitate expansion during the daytime. Understand, children? Right, we'll move on to the next. Okay, we have an activity to do. This is very important to understand more about expansion. Okay? So the activity is, let's learn about the expansion of solids. Okay? What are the things we need to do this activity? We need a marble or an iron ball. Okay? And we need a metal ring or metal loop like this. But remember, this metal loop should be smaller than that of the marble or the iron ball that we use. Okay? And we need a wooden handle to fix this metal ring. Okay? Let's write this. Marble, or we can use an iron ball. So in the experiment, I am going to show you this activity with an iron ball, okay? And here, metal loop. Metal loop. Right? So it should be smaller than the marble or the iron ball. Smaller than the marble. And we need a wooden handle so we can hold it very well. Wooden handle. Okay? So how to do this activity? Look at the method. We label the diagram first. So you have to fix this iron loop to the wooden handle like this. This is the iron loop and this is the iron ball. Wooden handle. Metal loop and iron ball or marble. So you can make this at home very easily. You all can find a marble and a metal wire. Okay, using a metal wire, you can make a loop like this and you can make this setup. So how to do this activity? Fix the iron wire with the loop to the wooden handle as shown in the figure. Right? So this is the wooden handle and the metal loop. We have to fix them together. And then you have to place this iron ball on the metal loop and check what happens. You will realize because we use the metal loop smaller than the marble, what will happen? This marble or the iron ball will not go through the loop. Okay, let's write that as well. Place the iron ball on the metal loop. On the metal loop. And observe what happens. Okay? Then heat the loop using a flame. So first you are going to fix this handle to the loop and then you are going to place the iron ball on this loop and you are going to realize that it will not go through the loop. Okay? Because initially I mentioned that you have to make this loop smaller than the iron ball or the marble that you are going to use. Okay? Now, you have to heat the loop using a flame. You have to take the iron ball out. You have to heat only the loop. Right, children? You have to heat it for about 1 minute. Right? Now check whether the marble can be sent through the loop. So after heating the metal loop, you have to place the iron ball again on the loop and check whether this time it goes through the iron loop. Let's do this activity. Right, children. Now we are going to do this activity to check what happens when we heat solid substances. Right. Look what I have here. Here, this is an iron ring. You all can see it very clearly. This is an iron ring. And this is an iron ball. Right? Both made with iron, a ring and a ball. Right? So I am going to place this ball on the loop, this iron ring or the iron loop. What happens? This ball does not go through the loop. Right, children? You all can see it very clearly. We cannot send this ball through this loop at this time. Now what I am going to do is, first I am going to light the spirit lamp. And now I am going to heat only the iron loop or this ring. I'm going to heat it up very well, but I'm not going to heat the iron ball. So after heating, now I'm going to place this iron ball again on this iron loop. What happens this time? It goes through the iron ring. Right? Earlier, it did not go through the iron ring, but this time, it nicely goes through the iron ring. What is the reason, children? Now, earlier, before heating the iron ring, we could not send this ball through the iron ring. But after heating, what happens? Because of the heat, when the solid substance absorbs the heat, what happens, children? The size of the iron ring increases. Okay, that is why after heating, we can nicely send this iron ball through the iron ring. Right? So this iron ball and ring, both are considered as solid substances. So what happens to the solid substances when we heat it? It's very clear after doing this activity. When we heat the solid substances, the size increases. Okay, children, the size increases and this is known as expansion of solids. Understand, children? Now I'm going to let this iron ring cool again and after a little while we'll check. Right. Now we let this iron ring cool down. Earlier we heated it up. Now I let it cool down. I'm going to place it again. What happens? Again, we cannot send this iron ball through the ring. What happens? Which means when cools down, these solid substances, the size reduces. Right? This is known as contraction. So it's very clear When we heat solid substances, its size increases, and this is known as expansion. Okay? And when the heated substances cool down, again the size reduces, and this is known as contraction. Okay, children. So what happened? Do you remember what we did? We used the setup like this. Now earlier what I did was I placed the iron ball on this metal loop, and the iron ball does not go through the metal loop, which means the metal loop is too small for the iron ball to go through. Okay, so then I removed the iron ball and I heated only the loop for about a minute. And after heating it up, when I place the iron ball, what happened, children? It nicely goes through the loop, which means this time after heating, the size of the metal loop has increased. Right, children? So then what happens? When this metal loop cools down, after it cools down, when I place this iron ball again on this metal loop, what happens? Again, it doesn't go through the loop, which means when this metal loop, the heated metal loop, cools down, what happens? Again, its size reduces. Understand, children? We'll write these observations. I'm going to write them in 3 steps. Right? Before heating the loop. Before heating the loop, the iron ball does not go through the loop. After heating the loop. The iron ball goes through the loop. When the heated loop cools down, again the iron ball does not go through the ball. Okay, children? Before heating the loop, the iron ball does not go through the loop. After heating the loop, the iron ball goes through the loop. When the heated loop cools down, the iron ball does not go through the, it should be loop. Loop. Okay, when the heated loop cools down, the iron ball does not go through the loop again. Right? So what is the conclusion after doing this activity? It's very clear what happens to the size of the solids. Now here this iron loop is a type of solid. So we heated it up, then what happens? Its size increases. Now you all know this is known as expansion. Okay? Right, conclusion. When heat is supplied to solids, they increase in size. This is known as expansion of solids. Expansion of solids. When heat is supplied to solids, they increase in size. This is known as the expansion of solids. Okay, children? Let's move on to the next. Right. We have a question to answer. How can we remove a metal lid from a bottle? Now, sometimes you must have experienced this, children. Sometimes the glass bottles with metal lids, when the metal lid is too tight, sometimes you can't open it. Now, as you already learned about expansion, can you suggest a method to remove a lid like this, children? You all know that the objects, the solids expand, the size of the solids increase when we supply heat, and this is known as expansion. Okay, children? So how can we remove the metal lid from a bottle? We can pour some hot water onto the metal lid, or very simply we can hold the metal lid of the bottle to a flame. Right? We can directly hold it to a flame, and then what will happen, children? Its size will increase, which means it will expand. When its size increases, we can easily remove it. Okay, children? We'll draw a small diagram for this one. If this is the metal lid that is fixed to the bottle tightly, what can we do, children? Right. Draw the bottle like this. Right? So if this is the metal lid that is tightly fixed to the bottle, what we can simply do is, we can simply pour some hot water onto this metal lid. Or we can hold this metal lid part to a flame directly. Okay, so then what will happen? This will expand. What is the expansion of solids means? The size of the solids will increase when we heat them. Okay, that is known as expansion. So it will expand, its size will increase, and thereby you can remove the lid easily. Right? Let's write this one. Heat the metal lid by holding onto a flame or by pouring some hot water. Then the metal lid will expand. Here what happens? Size increases. Size increases. Then we can remove the lid easily. Okay? How can we remove a metal lid from a bottle? Heat the metal lid by holding onto a flame or by pouring some hot water. Then the metal lid will expand or size increases. Then we can remove the lid easily. Right? So now it's very clear what expansion is. What is the meaning of expansion? Substances increase in size when we heat them, and this is known as expansion. We'll write a small note for expansion. So what is expansion? Substances increase in size when they get warmer. This is called, this is known as expansion. Okay, let's go back to the experiment. Now you all know in this third instance, you all know before heating, the iron ball does not go through the loop. But after heating the loop, what happens? As the size of the loop increases, the ball can go through the loop. But again, when the heated loop cools down, what happens? Again, the iron ball does not go through the loop. What is the reason for this, children? When the heated objects cool down, what happens, children? Their size decreases again. Okay, the size of the objects decrease because when they cool down. And this is known as contraction. Contraction is the opposite of expansion. Okay, let's write that as well. Right. Contraction. Contraction. Substances decrease in size when they cool down. This is known as contraction. So expansion. Substances increase in size when they get warmer, and this is known as expansion, which means when we provide heat to an object, it absorbs heat and the temperature increases and the size also increases, and this is known as expansion. Right? So contraction, substances decrease in size when they cool down. So because in here what happens? Because of release of heat, the temperature of the substances reduces and the size also becomes smaller, and this is known as contraction. Okay, children? This is known as contraction. Okay, children? Now we have completed this chapter. Do you remember what we learned under this chapter, children? We started to learn about the effects of heat. Under the first effect, we learned about increase of temperature, and under the second effect, we learned about expansion of substances. So under this chapter, we learned only about expansion of solids. In the other chapters, we are going to learn about expansion of liquids and gases as well.